Hello everyone, welcome. For this video, I'm going to go over stack in programming. And stack is a very easy concept to grasp as long as you understand how data is stored. Now let's start off with the definition of a stack. So a stack is a linear data structure. Now linear meaning that the data is saved sequentially. So each element have a previous and a next. However, when it comes to the first element, it doesn't have a previous, and when it comes to the last element, it does not have a next, right? So as long as you understand linear. Now, in computer programming, we do have different concept of linear. So we have stacks, queues, arrays, linked lists. These are all a linear data structure. So the ways of saving data in programming is either linear or non-linear. Non-linears, stuff like trees, like binary trees and stuff like that. These are non-linears. So if we look at the diagram, we can see that non-linear, they're saved in a hierarchy style, right? We have the parent and then we come down to the child nodes and stuff like that. However, in linear, it does not have a hierarchy. It's just one after another, right? So we have a previous and a next. Now, stack follows the LIFO approach, or last in, first out approach. Now, a last in, first out approach is like whatever you put in last, that's what's going to come out first. So an example of a last in, first out approach is when you take an elevator, right? The last person to go in the elevator is usually the first person to come out the elevator, right? Another example is, let's say you have a stack of plates, right? The last one to go on top, that would be the first one to come out. So what's a real world example of stack? Like, where would you implement a stack? Let's take, for example, on your computer system or on your OS, right? When you're writing on Microsoft Word or stuff like that, you have the undo and the redo button, right? So when you undo an error or when you undo something in Word, you undo the last thing in the stack, right? The main concept of stack is the top. When you're dealing with stacks, you have a couple functions that you have to write in order to implement a stack properly. But the three main functions, push, pop, and pick. Sometimes when people write out stack codes, you will also find functions like is full and is empty. With stacks, if you add a plate on top, that means you push something on the stack. If you remove a plate from top, that means you pop something out of the stack. And keep in mind that you cannot remove from the middle or from the end. You can only remove from the top when it comes to a stack. And if you want to see what's on top of the stack, then you would have to write a pick function. Okay. Now, a stack can be implemented using an array, linked list, or dynamic containers, right? And if you know how to implement an array, implementing a stack would be pretty easy. So for this tutorial, we're going to implement a stack using an array. And then in the next video, I'm going to continue this series where we implement a stack using a linked list and implement a stack using a dynamic container. Now, there are packages you can use from the standard library that will help you to implement a stack better. So we have functions that you can use. But for this video, I'm going to do it manually so you can understand how to program using stacks, right? So I'm going to strengthen the brain a little bit. Now, for this tutorial, I'm going to use C++, which is my favorite language. But you can also implement that using Python. The concept is the same. As I always say, when it comes to programming, the concept always remains the same, but the syntax is a little bit different. So I'm going to implement this using one file. I'm not going to create a header file. I'm just going to do everything in a .cpp file. So for me to implement this stack, I'm going to use a class. So the first thing I'm going to do is include my header file. So I'm going to say pound include, and I want to include the IOStream file. I'm going to use my using namespace std. I have all of the packages that I want. So to implement this stack, I'm going to use a class. So I'm going to say class, and the name of my class will be stack. And then I have my open and closing braces. If you don't know how to write a class, when you are creating a class, this is how you create the class. You say class, the name of your class, and remember the end supposed to have the semicolon. Now, in my class, I want some private variables or some private properties. So the first thing I'm going to have is an int, and I'm going to call my int ARR for array. Now, this will be let's make it a pointer. So for this code, I'm going to comment a pointer to hold the array. This is a pointer, so this will point to the array that holds the value. Now, one thing I must say before I go on, when the pointer points to an array, it doesn't point to everything. It points to the first value in the array. Just remember that. Now, the next value I'm going to want, or the next value I want in my stack, is a top variable. And the top variable will hold the top of the stack. Okay, so remember, in a stack, every operation happens at the top. So the top variable will give you back what's on top of the stack, the value that's on top of the stack. Okay, so if I enter 1, 2, 3 in the stack, 3 is going to be on top of the stack. 1 is going to be at the bottom of the stack. So I'm going to just comment here, variable to hold the top of the stack. And then the last variable that I want is the size, and the size is going to be an int. So I'm going to say size, and size is going to track the size of the array. Okay, so if I put 1, 2, 3, that my size of the array is 3. This variable is to track the size of the array. Now, in my stack, I want some public methods or some public functions. So I have to use the specifier public, and in my stack, the first thing or the first method that I want to write out is my constructor. Okay, I need a constructor to initialize these variables. A constructor is simply the name of the class, right? So I'm going to say stack, right? I want to give my variable some type of initialization or some values. So first, I'm going to make my array a null pointer, and I also want to initialize top to -1, and I want size of my array to be about, let's say, 100. Now you can also do this. So you can say size is equal to 100, and okay, so I can say array equals to new int, and I'm going to put the size in here. So these are two ways you can initialize your variable. You can do it this way, or you can do it this way. Now, ARR null, when I initialize it to a null pointer, that means I just want to get some space for now. I don't want to initialize my array to, I don't want to initialize, like fully initialize my array. So for now, I want to make it a null pointer. So I want this to point to nothing as yet. Just get some space for me for now. Now, this here on line 12, this means that I want to store my variable dynamically. New means dynamic. Let me write this here. If I do this array or ARR, and I want to maybe say hold probably 5 space for me, or I can say size, right? If I do this, that means that the space in memory going to hold whatever size I initialize. So if I initialize size to 100, then the array would be 100 right here. But I do not want to hold 100 space in memory just in case I do not use all 100 space. I want to save my data dynamically. So when I save my data dynamically, it's going to save at runtime. It's going to save on the heap. When data is saved on the heap, that means it is saved at runtime. So when I'm compiling my code and running it, then it's going to make space for me on the heap. Once I'm finished running my code, everything is going to get deleted. Because I'm going to initialize my array dynamically, I'm going to have to use a destructor to destroy, to delete whatever I saved on that heap, okay? Or else you'll be in problems. So we must delete that. And to delete the values, we have to use a destructor. The destructor is just the same as a constructor, but you're going to have to use the tilde sign in front. And to delete the value is pretty simple. You just use the keyword delete, and we're going to use our array symbol, so the sign for an array, and we want to delete the values in the array. And that's all you have to write for the destructor. Now, in our stack, we have an is empty or an is full. So the first thing we want to do is we want to check if the stack is empty, and if it is empty, we're going to add stuff on the stack or in the stack. If the stack is full, we want to return and say, look, we cannot add anything to the stack. The stack is full for now. So let's go ahead and implement two functions, is full and is empty. So let's start with is full. Is full is going to be a bool. So we want it to return something if the stack is full. So I'm going to say bool is empty. And for our is empty function, we're just going to say return, and we're going to use the top variable. So return top equals -1. So if the top variable is -1, we're just using -1 as a code. So if top is -1, then we know that the top is empty. When it comes to computer programming, everything starts at 0, 1, 2, 3. This is just a red flag. If the top is -1, anything under 0, that means that the stack is empty. Because remember, everything starts from 0 when it comes to memory. We're going to save the values starting from 0 and then go up 1, 2, 3. So anything lower than is 0, that means our stack is empty. So that's why I put -1. -1 is just a red flag to tell me that the stack is empty. We're going to make this a bool as well. And we're going to say is full. And for this, it's pretty simple. Return top equals if the size -1. So this here is just basically saying if the top value equals to the size of the array. So if the size of the array is 100, -1, that's a red flag to say, hey, the stack is full. So if we go back to the diagram for linear, if we have memory 1, 2, 3, 4, when it passes 4, it's going to be garbage, right? It's going to go until it meets the end. When it meets the end, it's going to be garbage values. So if you go till the end, you have to do -1 to get back the last element in the stack. Because remember, in a stack, in linear, the pointer will point to the one after the last element. It doesn't point to the last element. It points to one after the last. So we have to do -1 to go back to the last element. Okay, let me show this quick diagram. So let's say we have, this is the stack, right? The pointer will point to the end of the last element in the stack. which will probably be garbage values. So if we want to get the last one, we have to do -1, and -1 will point us to the very last element. So that's why we're going to do size -1, and that will give us the last element. Now, if we look here, if you are new to programming, 2 equal signs is going to be equal to. It's weird, it's C++, but that's just how the syntax is. Before I implement the next function, bool returns true or false. Okay, so if the array or if the stack is empty, you can say if top equals -1, then return true, that the stack is empty. Okay, now, so the next function I'm going to implement is the push function. And the push function is pretty easy to write out. So the push function is going to be void, and we're going to call this function push, and inside of the parameter we want values. Now remember, values is the elements or the data you're going to push inside of your stack. And for the push function, we're going to check if the stack is full. If it's full, so to do that, we're going to say if is full. So if the stack is full, we just want to see out or print stack is full. Okay, or you can just say stack overflow. Let's use stack overflow to look a little bit cool. Stack overflow. So if our stack is full, we're just going to say stack overflow, and then we're just going to quit the program, return to the caller, right? We're going to return to main. If the stack is not full, then we want to populate the stack. So to populate the stack, we're going to say ARR, which is our array, and we're going to say ++ top. So put things on top of the stack, and then the stack ARR is going to equals to the value. So the value we're getting in from the parameter is going to store in this array here. That's what line 31 is doing. Take the value that comes into the parameter and save it in this array. Let's go down and implement the main function. So I can say int main, and inside of my main, I'm going to create a stack object. So I'm going to say stack, and my stack object is going to be my stack. And I'm going to do a print function, and I'm going to say values in my stack is, and for me to push values in my stack, I'm going to use a loop. Okay, now you can do this. My stack, okay, dot, and we're going to look for the push function, and I can push values in my stack this way. Okay, so I can go ahead and if I want, I can copy this and then print it and add a different value. But for this, I'm not going to do it this way. I'm going to use a loop. Okay, actually, let me delete this instead of a comment. So I want to use a loop to push values in the stack. So I can say for, and in my for loop, I want an int I, and I'm going to initialize this to 1. So instead of starting from 0, I'm going to start at 1. And then I can say I is less than, let's put 8, 7, let's put 8. I less than 8, and I want to increment I as it's going. Instead of my for loop, I'm going to say my stack dot push, and I'm going to push I. Okay, so what this line is doing, line 41, inside of my for loop here, I want to push the values inside of my stack. So I'm going to push 1, 2, 3, 4, 5, 6, 7, stuff like that. This is what this line is doing. This is going to push values in my stack. And then I want to print the values that is in the stack. So I'm going to see out or print the values I, or what's in the stack. Here I'm going to give a space for readability. Okay, so this is how you implement a stack. Now let's build the solution, see if there is no errors. And it says that 1 succeeds. So when I get this message here, I know that my program has been successful with no errors. So let's go ahead and run the program. Now you see here, the values in my stack is 1, 2, 3, 4, 5, 6, 7. Okay. These values here is coming from this for loop. I want to print numbers from 1 to 7. Now, if I change this to 0 and I build a solution again, so let me close this off, build a solution again, and start without debugging. If you look here, it starts from 0 because we make I equals to 0. I would start at 0 and still be less than 8. But for this, I want my values to start from 1. So this is the code to push values in the stack. Now, if I want to see what's on top of the stack, I would have to write a pick function. Now, let's go ahead and implement that pick function. That pick function will be an int, and I'm going to call my function pick. And in that pick function, I'll say if, right? The top, so which is my top variable. So if the top equals to -1, then I want to see out or print stack is empty. I'm going to just put, okay, I can say stack is empty. Actually, let me just do an end line. Okay, so if my stack is empty, then just return, right? There is nothing to see. So I'm just going to do return, just going to say return, and I want to return -1 as my red flag. Else, if the stack have value in there, I'm going to return AR, which is my array, and I want to see what's on top of my stack. So I'm going to say ARR top. Let me see what's on the top of my array. So I can come down to the main function and just print top value in my stack. And for this, I'm going to use my pick function. So I'm going to say my stack dot. You see here, when I put the dot, I get all of my properties and methods in my class. I'm going to say my stack dot pick, and that's what I want to see. Okay, let me put an end line. So let's build the solution and let's run it. So if we look here, what's on top of the stack is 7, right? Because actually, let me make this a little bit more readable. So right here, I'll just put a \n. Or you can put an end line right here. Okay, so either you put an end line right here or a \n here to go to a next line. Either or. Actually, I'm going to remove the end line. Okay, so I'm going to build my solution and I am going to run it. So here, this is the values in my stack. 1, 2, 3, 4, 5, 6, 7. What 7 is the last item to go on top of the stack. So if I pick in my stack, it will show me the last item. So that will be the first item that you will see. Now, the last thing that I want to write is the pop function, how to remove stuff from the stack. And writing a pop function is pretty easy. Okay, let's go ahead and implement this function. Now I can say void pop, and inside here, I want a reference to my pointer. So I'm going to say and out. Okay, so this here is just referencing my pointer array. Because remember, if I go back on top, array is a pointer. So if I want to get the values of that or to track it or to see it, I need to reference that pointer. And the &% means to reference, right? Referencing a pointer. So in my pop function, I can say if is empty. So if my stack is empty, then there is nothing for me to delete or pop. So I can just return. Don't do anything because it is empty. Now, if there is values in my stack, then my out variable, what is passed through the parameter, have it equals to or assigned it to array or ARR top minus minus. So basically what line 46 is doing, when this get a reference to my array, go ahead and delete it. Top minus minus will delete. Top plus plus will add. Now let's go to main and print after the stack is being deleted. So for this, I can use a while loop. So I can say while my stack is not empty. So I can say my stack dot, and I want to access the is empty function. So while my stack is not empty, I'm going to create a new variable called value, and I can say my stack dot pop, and I have to tell my program what do I want to pop. So for this part, I want to pop the values that is coming in. So I can say pop the values, and then I can see out or print the values. And that's all there is to it. Okay, I forgot to put my return 0 at the bottom, which you don't really have to, but I like putting my return 0 inside of main, right? This is my while loop in the main function. So I created a variable called value, which will track the values that is in the stack and delete them or pop them while the loop is going until it reaches to 0. So let's go ahead and build this solution and let's run it. Okay, so if we look here, this is our values getting popped. 7, 6, 5, 4, 3, 2, 1. Let me go ahead and put a statement here to say cout values deleting from my stack. And then we're going to print the values. So let's build a solution again and let's run it. So this here, this values in my stack, this is coming from this for loop, right? So we push in items in the stack. Then we use the top of the stack, right? My stack dot pick. We want to see what's on top of the stack. And then we want to delete from the stack. Oh, from is spelled wrong here. Let me just change this quickly. FROM. Okay. This is value deleting from my stack. And we're just going to delete 7, 6, 5, 4, 3, 2, 1. Now, if we go and pick what's on top of the stack, let's copy this line of code. Let's put it on line 64 right after we empty our stack. Let's see what's on top of the stack when we delete all the values. We're going to build. Let's close this off and let's run it. So you see here, top of my stack is empty and I return -1. Okay, so if I come on top and show the function here, stack is empty. Okay, if I start here, see here, stack is empty and I return -1. There is nothing in my stack. Okay, my stack is empty because I just deleted what's inside of my stack. Okay, so there's nothing for me to pick, nothing for me to see. It's empty. Now, let's go here on top here. Because the size is 100, let's decrease this size. Okay, let's make size equal to 10. Because we decrease the size now, size equals to 10. Let us do this, 20, and see the message that we're going to get. Now let's run the program. And you see here, when it reaches 10, it's going to say stack overflow. That means our stack is full because we only reserve space for 10 items. And after 10 items, it's going to say stack overflow. okay, which is going to be here. When we push it into the stack, once it reaches 10, it's going to say stack overflow. Okay, that means we're pushing more item in the stack that we didn't make space for because we changed the size of the array. Okay, so that's how you implement a stack in C++. As I said previously, you can implement that same stack using Python, just to say the syntax or the way of writing it out will be a little bit different. The concept and the idea is the same thing, but the way how you implement it, the syntax is different, obviously. So that's it for this video. Hope you have learned something. If you did, please don't forget to like, subscribe, share, and I will see you in the next tutorial.